In this lecture, I am going to discuss about a very important principle which is used to find electric force when there are a system of charges. It is called a principle of superposition for electric force. According to principle of superposition for electric force, the net electric force exerted by a of point charges on a point charge is the vector sum of all the forces exerted by individual charges on that charge. Mathematically, F net means net force. Since force is a vector, we will write vector symbol also. F net is equal to F1 plus F2 plus etc plus Fn. If there are n charges, then this is the statement of principle of superposition. Net force on any charge is the vector sum of all the forces. Now I will discuss what is meant by this. So for that, consider a system of charges. For simplicity, let us consider a system having three charges. So I am considering a system with three charges Q1, Q2 and Q3. Now this is a system which is having three charges Q1, Q2 and Q3. Now I want to find the net force on Q3. This is my aim. I want to find the net force on Q3. But from the figure you can see that there are three charges, and on Q3, Q1 as well as Q2 both will exert force. Here itself you can see Q1 will exert a force on Q3, Q2 will also exert a force on Q3. You want to find net force. Net force means force from Q1 as well as from Q2 will be acting on Q3. So how to find the net force on Q3? For that you can use this principle of superposition. How you can use it, I will explain here. So listen. So first thing you must know is, whenever there are charges and you are going to find force on any particular charge, there is an easy method by which you can find it. So the method is like this. You are going to find the force on Q3, net force on Q3. So first thing is that you must imagine that you are standing on Q3. When you are standing on Q3, you can see two charges. One is Q1, another is Q2. Both will exert force on Q3. So you are standing on Q3. Now electric force, the nature of electric force is that electric force will be always acting along the line joint. So if you consider Q1 will exert a force on Q3. That force will be always in this line joining. Say in a similar way, Q2 will exert a force on Q3, either attractive or repulsive, depends upon the charge. But the thing is that the force will be always along this line joining. Hence, the force exerted by Q1 will be in this line joining, so that it can be in this direction or in this direction. In the same way, the force acting on Q3 due to Q2 can be either in this direction or in this direction, depends upon attractive or repulsive. If it is repulsive, means the force acting on that charge will be away from the other charge which is exerting that force. So repulsive means the force will be in this direction, it will move in this direction. If it is attractive, then force will be in this direction. Similarly, if Q1 is exerting a repulsive force on Q3, then force will be in this direction. And if Q1 is exerting an attractive force on Q3, force will be in this direction. Now coming to the problem. First let us consider that all the charges are positive charges. Q1, Q2 as well as Q3, all are positive charges. Okay, if you consider like that, then in the given problem First, find the force on Q3 due to Q1 and Q2. So for finding force, you need to find the direction of force. We consider that all the charges are positive. Q1 is positive, Q2 is positive, Q3 is positive. Now draw the line joining Q1 to Q3. This is the line joining Q1 to Q3. And force will be always along the line joining, either in this direction or in this direction. So for the given problem, Q1 and Q3 both are positive charges. Positive means Q1 will exert a repulsive force on Q3. So the force acting on Q3 due to Q1 will be repulsive. Repulsive means it will be in this direction. Attractive means it will be in the opposite direction. Okay, attractive means it will be towards the charge which is exerting force. Repulsive means it will be away from the charge which is exerting the force. So this is F1. F1 means force exerted by charge Q1 on Q3. In the same way, there will be a force exerted by Q2 on Q3. So for finding that, first draw the line joining Q3 and Q2. This is the line joining Q3 and Q2. Now in this line joining, since Q2 is positive, Q3 is also positive and positive, there will be repulsive force. So the force exerted by Q2 on Q3 will be repulsive. Repulsive means it will be in this direction. Repulsive means it will be away from the charge which is exerting that force. Attractive means it will be towards the charge which is exerting that force. Here you can see the arrow is moving away from Q2. Okay, if it is moving in the opposite direction, if it is moving like this, means it is towards charge Q2. That is for attractive force. Here this arrow is in this direction, means it is moving away from Q2. It is moving away because it is repulsive force. Now you can see there are two forces acting, and this force, second force, is exerted by Q2. So it is called F2. Both the forces are vectors, so you can note down with a vector symbol. Now you can see there are two forces acting on Q3. So in 11th class you studied about vectors. When vectors are acting in different direction, there will be a resultant vector. So in this case, forces are vectors, and hence the resultant force will be in this direction. This is the net force acting on Q3. So you can find the direction of resultant force acting on Q3, that is given by F. Okay, now according to principle of superposition, what this principle is saying, according to this principle, net force on Q3, F net on Q3 is equal to the vector sum of all the forces exerted by individual charges. Other than Q3, there are two more charges, Q1 and Q2. They are exerting force on Q3. So the total force on Q3 is the vector sum of individual forces. Okay, that means force exerted by Q1 plus force exerted by Q2. You must add it using vector method. So force exerted by Q1 is F1 plus force exerted by Q2 is F2, and its direction you will get from the diagram itself. It is in the direction of F. Okay, so according to principle of superposition, you can find it. Now let us consider another case. You are having four charges, Q1, Q2, Q3 and Q4 around the sides of a rectangle. Okay, if you consider this diagram, it is just looking like a rectangle. Now your aim is to find the net force on Q4. You want to find the net force on Q4. So how to find it? It is a system of charges, so that you can apply the principle of superposition. According to this principle, how to find net force on Q4? First thing is that imagine that you are standing Q4. So in this case, imagine that you are standing on Q4. because you are going to find the force, net force on Q4. You must imagine that you are standing on Q4. Then find the individual forces acting on Q4 due to all the other charges. Instead of Q4, there are 3 more charges, Q1, Q2 and Q3. All the 3 charges will exert force on Q4. Find those individual forces. Then add the net forces using vector addition. You will get the net force. Okay, so let us find the forces. First, Q1 is exerting a force on Q4. To find that, draw the line joining Q1 and Q4. This is the line joining, and hence the force exerted by Q1 on Q4 can be in this direction or in this direction, depends upon the sign of charge. First, let us consider that Q3 is negative, Q2 is also negative. Let us consider a different problem. Okay, so here 2 charges are positive and 2 charges are negative. Q4 is positive, Q1 is positive. Now Q1 is positive. If Q1 is positive, then Q1 will exert a repulsive force on Q4 because Q4 is also positive. Positive and positive are like charges. So there will be a repulsive force acting on Q4 due to Q1. Repulsive means it must be moving away from the charge which is exerting the force. So a force is exerted by Q1 on Q4. So it must move away from Q1. Move away means it will be in this direction. That is F1. Okay, F1 vector. Now there is another charge Q2. Q2 is negative. So find the force exerted by Q2 on Q4. For that, draw the line joining Q2 and Q4. Force will be in this line joining only, either in this direction or in this direction. So how to find the direction? Consider the sign of charges. Here Q4 is positive, Q2 is negative. They are unlike charges, and hence Q2 will exert an attractive force on Q4. Q2 will exert an attractive force on Q4. Attractive means the force must be moving towards the charge which is exerting that charge. Who is exerting the force? Q2 is exerting the force. So the force must be attractive. Attractive means it must move towards that charge. That means this will be the direction. This is F2 because force exerted by Q2 on Q4. So you got 2 forces. Now one more charge is there, that is Q3. Q3 is exerting force on Q4. Q3 is negative charge. So first draw the line joining Q3 and Q4. This is the line joining. Now Q3 is exerting a force on Q4. You want to know whether it is attractive or repulsive. Here Q3 is negative, Q4 is positive. So they are unlike charges. Then force will be attractive. Attractive means the force must move towards the charge which is exerting that force. Here Q3 is exerting the force, and it is attractive because Q3 is negative and Q4 is positive. So the force must move towards the charge which is exerting the force. Q3 is exerting, and hence force must be in this direction. This is F3 because it is exerted by Q3. Now you can see there are 3 forces, F1, F2 and F3. I am considering the diagram separately here. You are having a charge Q4 here. On Q4 you want to find the force. So one force is in this direction, F1. Another force is in this direction, F2. And another force is in this direction, that is F3. All are vectors. Now what is the resultant force? According to principle of superposition, the resultant force F net acting on Q4 is equal to F1 plus F2 plus F3. This is the resultant force acting on Q4 according to principle of superposition, isn't it? So I hope it is clear. Now in the next lecture I will solve some problems related with this concept, then you will get more clarity.